I want to just make sure that people understand mathematically what we're actually doing when we apply these present worth, annual worth methods of analysis, and when we use the MAR. And really, it always comes back to this concept of equivalence. So when we understand fully the time value of money and how it allows us to move cash flows through time, it also lets us make decisions about things that we wouldn't normally be able to decide, if something is a good investment or a bad investment, because you can't just do the math in your head anymore. And let me just, I'm just going to pull an example sort of out of my head. If I, let's say I invest something like $10,000. If I invest $10,000, and when I say invest, I mean maybe I'm buying a piece of equipment for my company, or maybe I'm buying some type of a guaranteed investment certificate that pays me a certain amount, or maybe I'm buying some other type of investment, or maybe I'm lending the money to a startup company. Whatever it is, we have some negative down arrow. Okay, that's very important. So at the beginning of this so-called project or investment, at time t equal to 0, we have some investment, and that shows up as a down arrow on our cash flow diagram. And mathematically, we're going to importantly note that that contains a negative number. Now, whenever we make an investment, we also expect that we'll have some type of a return on that investment. So let's say that we look at something like, I don't know, let's say 6 years. So here's 1, 2, and we'll just, I mean, these are arbitrary time periods. Let's just say there's 6 years. And let's say that this investment returns, I don't know, let's say it returns something like an annuity. So it gives us a constant return, some annuity. And let's say that this annuity is, let's say $2,000 every year. That means I invest $10,000, negative, comes out of my pocket. I receive $2,000 a year for the next 6 years. And you think, oh, okay, well, anyone looking at this would say, well, that's a good investment. This gives me $12,000. I only invested 10. What's wrong with that statement? In the chat, please. What is wrong with that statement that I just said? This gives me $12,000. I invested 10. You cannot compare time value of money. Thank you very much. Well, someone says bad deal. Well, time value of money is really what I was looking for. Remember that golden rule. You cannot add and subtract dollar amounts that occur at different points in time. So if I have all these $2,000 occurring at all these different times, I can't add them up. I can't say $2,000 times 6 is $12,000. You can't do that. Can't do that. Doesn't work. And if I'm investing 10,000 and then I'm receiving this cash flow, I don't know if that's a good investment or not. I need to know, at what interest rate do I use to make this comparison? And let's say, if I have an interest rate like I don't know, 8%, and I'll use the jargon from this chapter, which is that minimum attractive rate of return. Let's say my minimum attractive rate of return is 8%, meaning that any investment that I put my money into, I need to get an equivalent 8% return. And the only way I can determine if this investment meets that criteria or not is to do the time value of money calculation. And the time value of money calculation using something called present worth essentially takes all of the cash flows and uses 8% in the time value of money and brings them back to the present and tells me what the value is. Now, I can say, so for instance, this one, I could say the present worth is going to be equal to my investment, which is negative 10, I'll just put K, negative $10,000, plus positive amount, which is my 2K, times the P given A, because the 2000 is an annuity, an A, at 8% and 6 years. Okay, so if I work out what that is, I don't know what that is. Maybe that's a good test. So how do we do this? Well, we say, so step one is just knowing how to write the time value of money sort of equation to convert, to bring all of this to the present worth. That I didn't have to use any compound interest factor on the 10,000 because it's already at the present, right? The present is here at time t equal to 0. That's the present. So I need no modification to the 10,000, but I do need a modification to the 2,000. So I'm going to flip to my 8% compound interest table for n equal to 6, and I'm going to look in the column of the P given A. Right, so the P given A for 8% and 6 has a value of, so I'm going to say here negative 10K plus 2K times the compound interest factor. Someone said, oh, someone's already given me the answer. That's good. Let me just show how we get it though. 4.6229. Okay, make sure that you know how to get that, right? So I went to the 8% table. I went in the column for P given A. I went in the row for n equal to 6, and I came up with this compound interest factor. And then if I work this out, well, that ends up with, and someone said that I end up with negative 0.7542. That's negative 754. Okay, I'm gonna just trust that someone has done that correctly. I'm going to say, there we go. So the present worth is negative 500. Someone says, yes, that's good. Negative $754. Okay. What does that mean? Oh, someone asked a quick question about, someone says that's a bad deal. Okay, well, that's right. We'll get to that reason why in a second. And someone said, quick question, could the MAR actually be compounded monthly? Yes, it could. Right. So in a question like this, if the MAR was 8% compounded monthly, you'd have to calculate an effective yearly interest rate, right? Because our cash flows are every year. If our cash flows are every year, then we need an interest rate that's every year. So if that was compounded monthly, I'd need to convert that to an equivalent yearly, and then I'd have some non-round number down here, which means I'd have to use the formula for P given A. I couldn't use the table, but that's a quick answer to your question. But I'll address what this means. Someone said this means it's a bad deal. Well, specifically, I want you to think about the time value of money, and I want you to think about what a negative present worth means. So I invested $10,000. I got $2,000 a year for 6 years back, and I expect an 8% rate of return. I end up with a negative present worth. What does that mean? I know someone said it was a bad deal, and yes, but more specifically, what does that mean? Any thoughts? So yeah, someone has said the right answer. Basically, a negative present worth means that this investment is giving me something less than 8%. Right? So it means that if I take all of these cash flows, convert them to the present worth, they end up as a negative value. Now, if I were to reduce the interest rate, right? If I reduce the interest rate, then maybe I can make this turn into an investment that has a positive present worth, which is basically saying that my expectation is lower for the rate of return. And if this number ends up positive, then that means I would meet whatever that minimum attractive rate of return actually is. Someone says, this is very important. Someone says, you lost $754. Very tempting to conclude that, but be careful. To be accurate, you would say that this investment has a negative present worth of $754, it doesn't really mean you lost $754. And to some extent, the actual 754 as a number isn't really that important. It's just telling, the negative is just telling us we didn't meet the MAR, and the 754 is sort of by telling us sort of by how much. But over the life of this project, there will never be a dollar amount of $754 appear anywhere, right? It's only appearing because we're doing this present worth calculation. Okay, there's someone said $754 of disappointment. And someone else said you're $754 below recouping your initial investment. Kind of, but again, still be very careful about what you're saying, because this calculation is really very accurately meaning that the present worth of this investment is negative 754. So, but don't get hung up on the dollar amount 754. We will use it, let's say I had another project over here that had a different investment amount, different series of cash flows, but it might have some numbers in it that really, honestly, I can't tell which project is better, because if I've got a MAR of 8%, the time value of money, funny stuff that goes on in there doesn't let me just look at the numbers and do it in my head. I actually have to do the time value of money calculation to decide which is better. So if I end up with something like negative 754 here, and I end up with another project with, let's say, negative 100, I could say the negative 100, well, that's not as bad as negative 754. But neither one still meets my minimum. Okay, so anyway, so someone says you could have still made money, you just didn't meet the MAR. Yes, that's actually true. That's actually true. So we'll in chapter 5, we move on to actually calculate the rate of return of an investment. And just as an aside, if I were to do the same calculation at, let's say, a different interest rate, and then I end up with a positive present worth, that would mean, oh yes, okay, this project satisfies my MAR. Let's say my MAR was 3%. If I did this at 3%, it would probably give me a positive present worth. But hypothetically, what does this mean if the present worth turned out to be 0? Right? What would that mean? If I have this investment, I do all these calculations, and the present worth ends up to be 0. What does that mean? Well, so one person said, yeah, I've got lots of really good answers. Yes, if the present worth is exactly equal to 0, that means that the $10,000 investment is exactly equal to the annual payment of $2,000 using an interest rate of 8%. So it means I exactly met my minimum attractive rate of return if the present worth equals 0. And you can kind of see a little bit of foreshadowing. If I were to not give you the 8%, and this is chapter 5, you could write this equation with some unknown value here and set these two things, set it equal to 0, take the 10,000 over to the other side and solve for the compound interest factor, and then figure out what rate of return makes the equation balance. We'll go back to one of the first classes where someone talked about, like in physics, when something is in equilibrium. Well, we can basically set this to equilibrium and solve for the interest rate that makes the equation balance, that tells us what the actual rate of return is on the cash flows. But we'll get into chapter 5. In chapter 4, we really just practice doing present worth and annual worth calculations, and then make sure that we know how to draw the correct conclusion from the results of these. Okay, so I don't want to dwell too much on this, because I do want to make sure we have time to to get into the rest of what we need to cover tonight. But I'll do one more thing before I erase all of this, and that is annual worth. It's also possible to analyze this problem using annual worth rather than present worth, and it works exactly the same. It's just the time value of money equation takes a different form. So I could write here the annual worth would be equal to, now in this case, I'm going to have $2,000. The $2,000 is already an annual amount. So I can write here that 2K, and that's positive, minus the 10K times a compound interest factor that converts a present value into an annuity, right? And that magical value is the A given P factor. So if I use A given P at 8% and 6 years, now I've just got a different form for the compound interest or the time value of money equation, but I can work this out, and it probably comes out to, well, let's actually do it just for fun. So this would be 2,000 minus 10,000 times the A given P factor for 8 and 6%. And I've still got this open, so I can just have a look here on the A given P column under 6, and it's 0.21632. So if I work this out, maybe someone can help me out here a little bit. Oh, actually, well, that would just be that would just be negative $163.20. Yes. Okay, so that's easy. I picked a nice example here. It's working well for me. I just picked it out of the air. That was a bit lucky. So if we end up with an annual worth, again, that's negative, we draw the same conclusion. That means that this time value of money equation is telling us that the investment does not give us a return of 8%. It gives us an equivalent yearly loss, let's say, of $163.20. It has an equivalent annual value that's negative $163. Don't be careful not to say it loses $163 a year. Well, it kind of does, but really we're not actually doing. We're just using this math to draw a conclusion, and when we get a negative number, we're not meeting the MAR. Interestingly, if I were to actually take $163.20 and draw a new cash flow diagram that just had 6 payments, 6 down arrows of 163.20, and I find the present worth of that, it would end up being negative $754, the same thing that we got in the present worth calculation. Okay, so anyway, we can draw the same conclusions using present worth or annual worth. And here's a tip for the midterm. There is a great advantage sometimes of using annual worth. Some people will say that annual worth is easier to explain to people because, in fact, it is a repeated amount that occurs every year, and people tend to think about things as a yearly loss or a yearly cash flow or something like that, rather than having it converted to a present value. Conceptually, that maybe that's a little bit more difficult for people. But there's another more important reason why annual worth can be a more powerful analysis tool. And that is when I have 2 projects that maybe don't have the same time frame. If I have 2 projects that have different time frames, if I use present worth, it's not really fair. It's not a fair comparison, and you can get the wrong answer. You can make the wrong decision, let's say. If I have 2 projects, if this is a 6-year project and I have another one over here that's a 4-year project, and I just do present worth, that's wrong. Mathematically, that is wrong, because I'm not comparing the full time frame of the analysis. I'm analyzing a longer time frame in one scenario than the other. It doesn't make sense. But in annual worth, it actually does. So there's a nice little feature of annual worth, and that is when you compare projects of so-called unequal lives, annual worth will give you will lead you to make the right decision, whereas present worth will not. Okay, so that's so anyway, that's my sort of conceptual introduction about what we're about to do in the rest of this chapter. And I'll just pause there for a moment and ask if there are any questions about that. Oh, someone says that negative 163.20 does not equal negative 754. Interesting. Yeah, but be careful what you did there. Right? You took negative 163.20 and you multiplied it by 6. You know, no, you can't do that. So let me just, so I'm sorry if you've already got this and it's like, okay, I've already got it, let's move on. Don't worry, because we got to make sure everyone is on board with this. It happens every year where people get left behind and it's not good. What I really mean is that you've got to take this 1, 2, 3, 4, 5, 6. So here's my 6, and you've got to do an annuity, you know, a negative annuity of 163.20. And if you find the present worth of this, so you take your annuity, negative 163.20, and you multiply it by the P given A factor for 8% and 6 years, that should equal negative 754. Okay, no, maybe someone has done that. Now so yeah, and you know, does that actually work? I mean, it should, and we did. If someone said yes, okay, so yeah, and we already had that value. That was the 4.6229 was the time value of money for that factor times 163.20. Yeah, there you go. So that's negative 754. Okay, so listen, I hope that answered the question, and I'm happy that you were listening when I said that, you know, you take negative 163 and do it for 6 years, it equals negative 754. But I'm talking about time value of money calculation. I'm not talking about adding dollar amounts that occur at different points in time. Okay, so I hope that clarified that. There's a good lesson in there for everyone, perhaps, or maybe at least for some people. Okay. Any other questions about that? Someone asked a question. Yeah, sorry. Someone said, so just like we kind of ignore, let's say, the meaning of that negative amount, if the amount is positive, and I'm sorry I didn't say this explicitly, but if the present worth is positive, then that does mean the project at least earns the minimum attractive rate of return. And then also similarly, you know, you shouldn't get hung up on what that actual dollar amount of the present worth is, because just like in the negative, that actual dollar amount doesn't really mean that it makes that dollar amount. It means the cash flow has an equivalent present worth of that dollar amount. But, you know, in the project, you know, in the company, there's no accountant in the company that would actually ever see that specific dollar amount. It's conceptually a number we use for decision making. Okay, so anyway, so I hope that is at least a little bit helpful. And then let me go back to our slides.